All right, let's do some examples of problems that I thought you could write down and then pause the video, give them a shot, and then start the video again and check to see if your answers are right. So I thought we could do that with these four problems. And then once we're done with these four, we'll do four more that involve division with scientific notation. So go ahead and pause the video, give these four a shot, and then start it again when you're ready to see how to do them. All right, hopefully you're feeling pretty good about what you did. Let's go ahead and begin with number one. Number one is 5 being multiplied by this scientific notation number. And remember, it's just a string of multiplication. This is not going to be distributed. This is not an addition or a subtraction symbol. It's multiplication. So really, this is just 5 times 6 times 10 to the 8th. And 5 times 6th we can go ahead and do, which is 30, which gives us 30 times 10 to the 8th, except this is not in scientific notation. We need to move the decimal from right here to right here because we can only have one digit to the left of the decimal when we're in scientific notation. Because we're moving at one place value, we need to change our exponent by 1. It's either going to move down to a 7 or move up to a 9. Let's check it. If we have 30 and we're moving our decimal 8 places this way, because it is a big number, we know it's a big number because this is a positive exponent. We move it this way 8 spaces to create a big number. If we're going to move it back into scientific notation, we have to go back all 8 spaces plus 1 more to give us 9 places that we're moving the decimal. So this becomes 3 times 10 to the 9th. So if that's the answer you got, nice job. If not, go back, watch the explanation again, and hopefully it'll make sense. All right, number 2, similar. We have 4 different things being multiplied together. We have 4.3 being multiplied with 10 to the 4th, which is being multiplied with 2, which is being multiplied by 10 to the 9th. So remember, you can go ahead and multiply the regular numbers together, and you can combine the powers of 10. 4.3 times 2 gives us 8.6. 10 to the 4th being multiplied with 10 to the 9th. We have 10 being multiplied by itself 4 times here, 10 being multiplied by itself 9 times here. That's all together going to give us 10 being multiplied by itself 13 times. Because there's only one digit to the left of the decimal, we have a number that is in scientific notation, so no need to adjust. Hopefully you got that one right too. All right, number 3, we have a power being applied to a number in scientific notation. Remember, you can just apply that power to each piece. So this would become 2 to the 4th, and this would become 4 sets of 10 to the 5th. So we have 10 to the 5th, 10 to the 5th, 10 to the 5th, 10 to the 5th. That's a lot of 10 to the 5th, which gives us a lot of 10s. That gives us 20 10s, 10 to the 20th. Remember, the shortcut is just to multiply your exponents. All right, so let's go ahead and finish this because this is not in scientific notation yet. 2 to the 4th is 16. It's not 8. 2 times 2 is 4, times 2 is 8, times 1 more 2 gets us to 16. Bring down the 10 to the 20th. Again, not yet in scientific notation. We have 2 digits to the left of the decimal. Move it 1 place value. So it's going to become 1.6. We know we need to change our exponent by 1. It's either going to move down to 19 or up to 21. Let's take a look. This is 16, and we're moving the decimal 20 times this direction because we're making a large number. If we went this direction, that would be making a very small number. Positive exponent, big number. So we're going to go 20 spaces that way, which means to put it into scientific notation, we have to come back all 20 spaces and go 1 more to give us 21. So 1.6 times 10 to the 21st power. All right, let's see if you got the last one right too. Hopefully you're getting them all right. All right, so this one again, very much like this one. The only difference is we have a negative exponent. I thought I'd throw one of those in just to kind of keep that straight in your head also. So we have 8 times 7 times 10 to the negative 6. We're not distributing. This is not an addition. This is not a subtraction. It's just one long multiplication problem. 8 times 7, 56. Bring down the 10 to the negative 6. If we want to make sure this is in scientific notation, check to make sure you have only one digit to the left of the decimal, and we don't. We have 2, so we need to move that decimal. We're moving at one place value, which means that this is either going to move to a -5 or a -7. Let's figure it out. If we follow the rule that we've been given, actually, I'm going to put this underneath because I'm going left with my decimal to make a very small number. If I were making a big number, I'd go this way, but because it's a negative exponent, we have to go this direction. So 6 spaces, 1, 2, 3, 4, 5, 6. Fill in the empty spots with zeros. That gives us 4 zeros followed by 56. To put this into scientific notation, we're going to move the decimal right there. So it is being moved 1, 2, 3, 4, 5 spaces, giving us 5.6 times 10 to the -5. It's negative because we have a very small number in standard form. So if you did not get each of these right and you're not sure why, go back, watch it again. Maybe the explanation will help. There's also a video that I've posted that can help you learn how to do this. So between these two things, hopefully you're getting it figured out. Let's go ahead and move on to 4 examples with division. All right, so here are 4 more practice problems, but now we're dividing with numbers that are in scientific notation. So again, write them down, give them a shot, and pause the video while you're working so that you have an opportunity to try it, and then you can turn the video back on when you're ready to check your answers and how it's done. All right, so let's start with number 5. Hopefully you were feeling pretty good about these as you were working. Let's see how you did. When you are dividing with numbers that are in scientific notation, you can break them into pieces. You can focus on the regular numbers and separately focus on the powers of 10. So here we have 6 divided by 3. It's not subtraction, it is division. 6 divided by 3 gives you 2. We're going to multiply that with, we have 10 to the 6th in our numerator, 10 to the 4th in the denominator. These 4 tens are going to pair up with 4 of these tens to create a bunch of 1s. And we're going to have 2 tens in the numerator being multiplied together left, which is 10 to the 2nd. The other thing you can do is remember your shortcut. 6 minus 4 leaves us with 2. The base stays the same. So hopefully you got 2 times 10 to the power of 2. Number 6, we don't have a number in scientific notation in our denominator. We just have a regular number. So that's what gets matched up with the regular number in the numerator. And this 10 to the -8 just kind of tags along. We might have to adjust things to get it into scientific notation, but for now, it's just going to tag along. So 9.6 divided by 3 gives us 3.2. And the 10 to the -8 tags along. It's already in scientific notation, so we do not have to change anything. We are done. Hopefully I got both of those right so far. Let's check number 4. Number 4, pair up your regular numbers, pair up your powers of 10. 4 divided by 2 is 2. And here we have something interesting going on. A couple different ways you can look at it. Because we have both of our exponents negative, it's basically saying that this one belongs in the denominator and this one belongs in the numerator. So if you wanted to, you could switch these two and make the powers positive, which would put 10 to the 10th in the numerator and 10 to the 6th in the denominator. And then when you subtract the exponents, you would get 10 to the fourth power. If you prefer to just use the subtraction with the numbers as they are currently written, you will get the same result. So kind of off to the side here, we would have 10 to the negative 6 minus negative 10, and you add the opposite, negative 6 plus 10 still gives us a positive 4 for our exponent. So either way, however you like to think about it, the answer is 2 times 10 to the positive 4. If you don't understand that, rewind, watch this again. I'm going to move this 8. It seems to kind of be in the way there. There we go. All right, so now we are going to look at the last one. Here's our regular numbers. Here's our powers of 10. 1 divided by 5 is not 5. That would be 5 divided by 1. 1 divided by 5 is 1/5. And 1/5 as a decimal is 0.2 or 0.2. Over here, again, we have a negative exponent, which tells you it's not where it belongs. It needs to move up. So we have 6 tens on top already. We're going to bring 3 more up to the top, which gives us 10 to the positive 9. If you prefer to use subtraction with your exponents to find that, it would be 6 minus negative 3 as your exponent. Either way, we still get positive 9 as our power on the 10. Except now we should notice that this is not in scientific notation. You cannot have a 0 in front of your decimal if it's in scientific notation. So we need to move the decimal 1 place. That means this is going to change by 1. It's either going to become an 8 or a 10. To find out for sure, follow the directions that are given right now, which say move the decimal 9 times to create a large number. That means it's going to move this direction 9 times. When we put it into scientific or into standard notation, then it's going to become a 2 followed by 8 zeros. We had to go 1 space to get past here. We've got 8 more, which gives us 200 million. Putting that into scientific notation, you're moving the decimal from here to here. That means you are moving it 8 places, 3, 6, 7, 8. So 2 times 10 to the positive 8. It's positive because our standard form number is large. So hopefully you got all 4 of those right also, which means you're understanding how to multiply and divide with scientific notation pretty well.